Okay, displacement in the nth second of the journey. Let us consider a particle which is travelling with constant acceleration and the initial velocity is u, and assume that it covers distance s. Now, the final velocity is v. Now, let us consider the displacement in the nth second of its motion. For example, this corresponds to first second, this corresponds to second, third, fourth, etc. So, if I look at the enlarged diagram, let us assume that this is third second, this is fourth second, this is fifth second, etc. I will show everything here. This is 0. So, this is the distance travelled in the first second, this is the distance travelled in the second second, this is the distance travelled in the third second, this is the distance travelled in the fourth second, and so on. So, you may notice that the distance travelled, for example, in fifth second is nothing but distance travelled from t is equal to 4 seconds to t is equal to 5 seconds. Likewise, distance travelled in 10th second is nothing but distance travelled from t is equal to 9 second to t is equal to 10 second. Likewise, if I am interested in distance travelled in the nth second, so clearly it must be the distance travelled from t is equal to n minus 1 second to t is equal to n seconds. T is equal to n minus 1 second to t is equal to n second. Now, keeping this in mind, let us get the expression for this one. So, we have it here. Initial velocity is u, acceleration is a, this corresponds to t is equal to n minus 1 second, and this corresponds to t is equal to n seconds. Now, this is what I am looking for, distance travelled in the nth second. This is Sn. Now, let us treat this as S1 and let us treat this as S2. So, isn't Sn is equal to S2 minus S1? Yes. I will call this as equation 1. What is S1? S1 is equal to u n minus 1 plus half a n minus 1 square. S1. I am using S is equal to ut plus half a t square. Similarly, S2 is equal to ut plus half a t square. In the place of t, I have this. This is equation 2. So, with this, the equation 1 takes the form Sn is equal to S2, that is un plus half a n square minus, what is it, u into n minus 1 plus half a into n minus 1 whole square. Let us simplify it further, un plus half a n square minus, let us simplify this one, un minus u plus u, then minus half a, this is nothing but n square plus 1 minus 2n. So, it further simplifies to un plus half a n square minus un plus u minus half a n square minus half a plus half a into 2n. So, if you simplify it further, you get Sn is equal to u plus a by 2 into 2n minus 1. So, the distance travelled during the nth second, let me repeat, this is the distance travelled during the nth second, not in n seconds. During the nth second is given by u plus a by 2 into 2n minus 1. Let me repeat, this is the distance we are looking for, n minus 1 second to n seconds.